All right. Hey, everyone. My name is Mrinal. I am CTO and co-founder of Autonomy. And Autonomy is a platform for you to build and ship products that use teams of deep work agents to autonomously perform long and complex tasks. And that QR code over there is in all my slides, I think. And it's at any point, if you find it interesting, please scan it and sign up. If you sign up today, we'll give you $50 of free credit to try stuff. OK, so tell me if anyone saw this tweet last week. Yeah, there are a few people, right? So essentially, Cursor, this is the CEO of Cursor, he put out a tweet saying, hey, we let a swarm of agents work on building a browser for a week. And at the end of the week, it kind of worked, right? So they had hundreds of agents working on, I think, 3 million lines of code to eventually produce a browser, right? So he talked about this. And I think this is a first glimpse of what's coming through this year, next year, et cetera, of how things will behave. And it will not be about generating code. It will be about all sorts of domains and difficult tasks in those domains, right? Whether it's an agent defending your infrastructure in AWS automatically. It's just watching logs. It finds someone attacking it. It automatically figures out what commands to run and defends it, right? And this can't be one agent. It has to be a fleet of agents if you have large infrastructure. Or it's an agent that's preparing all the documents that currently humans work on for 2 years to get a drug approved. Or it's an agent that is like working at a law firm to prepare arguments and material for a legal case. I think this is coming. It's already possible. So it's problems that are too complex for a single agent. And so what I did is I built one yesterday. So let me show that to you. And hopefully live demo will not go crazy. So the agent I built was, here's a big code base. Review every file in it from lots of angles, from security angle, from code quality angle, from documentation angle, and give me a final report. That's what I wanted to build. In this case, as an example, I put in Vue.js as a repository. I'm saying look at it from multiple angles. And Vue.js, I think, has like thousands of files. And I click Analyze, and a bunch of agents spun up. And these agents are they're currently doing like a first pass. And they're looking at each file and going, do I need to do deep work on this particular file, or is it good enough? Is it simple? It's like a simple config file. And a few seconds later, what we'll see is for over here, there's like a little kind of like low risk, high risk kind of level being determined. And all the high risk ones, it's going to then spin up a whole new batch of agents per file, looking at deeply that file. And it'll write tests on that file. And it'll do all sorts of like complex work around analyzing that file, not just reading the code, but like really truly testing it and evaluating it from all sorts of different angles. And we'll give it 1 second to spin up that next batch of expansion. Otherwise, I'll show you a quick video of it. Okay, well, we'll look at a quick video of how this proceeds, okay? So this is a recording of this that I did earlier. A few agents spun up. If I speed this up, this is what's going on in our live version currently. And a little while later, you'll notice that some of the files are identified as high risk, and then a deeper analysis has started of more agents, right? Each little dot here being an agent. I didn't say that explicitly, but it's working. And in my case, I ran it for like a few hours. But that's the same kind of capability you need to run on complex things, right? And eventually, it's going to produce the reports we need. By the end of it, in this particular run, I had 5,200 or so agents running in parallel. And now I have some other video that YouTube decided we should look at. But you get the idea, right? And if I go back, not yet. They're still working. So my point is that this is now already possible, and all sorts of new types of things unlock because of this. So agents that were built in kind of the last 2 years were little script-like agents in my view, right? Like they could take a few autonomous turns. They could do maybe 3 steps on their own, 10 steps on their own, 20 steps on their own. But the agents I just showed you can take hundreds of steps or thousands of autonomous steps without any direction. And we all use an agent like this. Claude Code does this, right? Claude Code does this. It's able to do long, multi-hour sessions. Cursor showed that it can do week-long sessions, right? But to do that, you need a bunch of capabilities built into your agent. This include things like giving each agent a file system. So if you have a swarm of 5,000 agents, you need 5,000 little file systems that are isolated from each other to allow each agent to work on its own. You need progress tracking, like a to-do file. You must have noticed Claude Code create to-do files and track what it's doing. This is really helpful in limiting context and focusing on a problem in one step and then handing over the context to the next step and so forth. You need to give the agent the ability to take notes and collect structured data. All of this, you need to give it the ability to run command line. Sharam was earlier showing like how kubectl is better than like trying to do some custom tool, right? So you need agents that can run their own command lines, right? So, and you need agents that can spawn other agents or sub-agents. And harnesses like Claude Code and Autonomy, which I just showed you, can close this gap for a single agent with all of these capabilities, file system tools, memory compaction, shell access, sub-agent delegation, and so forth. But Cursor didn't run one such agent. We're all used to running like 1 Claude Code on our machine, or 5 Claude Codes if you're being really ambitious, right? We're talking about hundreds, or if not thousands, of parallel agents working on for a long period. This needs more than a Python library harness. It needs infrastructure around it, right? You need infrastructure to run things in parallel without blocking, create agents dynamically, discover agents across machines, start new agents, stop agents, pass messages between them, maintain isolated workspaces, etc. Right? So you need this like infrastructure that's more than a Python library that you can get from like, I don't know, Claude Code SDK, etc. Right? So in Autonomy, it looks like this. This is a quick snippet from that example we saw earlier. You can just say, hey, give me 5 runners, or give me 10 runner machines, or give me 100 runner machines, and it will spin up those machines. And then your Python code can discover those machines, take a task, like all files in a code repo, and say, split this task into equal parts, or some complicated logic if you wanted to come up with that, and give each part to each of these runner nodes we just spun up, right? So that's what I'm doing in that for loop, where I'm saying, hey, for each runner and a batch, start a worker, file review worker on that particular node. So now we can distribute work across a collection of machines. So Autonomy gave us a collection of machines, automatically connected them, and we now have, with a simple for loop, the ability to distribute work across them. As a next step, once that file review worker starts on that other node, it then goes file by file and calls this review file function. And this review file function spins up an agent for that file that does the first pass. But that agent is equipped with a set of tools. So it can access a file system dedicated to it to look at that file, look at dependencies of that file, look at other files that use that file, etc. But it can also spin up sub-agents that conduct a deep review and specialize, right? So over here at the bottom, we define these like sub-agents that have their own workspace, their own file system, their own set of tools, and you can even pull in like linters, etc. So that's kind of how it works. And the whole thing is, oh, by the way, this thing's like spun up more stuff, right? It's at 2,500 agents at this point, and it's working, right? It's going to continue for a few hours. But the whole thing that I wrote is only a few hundred lines of code. My application was a little more complex. I was trying different things. But as you can imagine, this snippet that we just looked at is not very complex. You didn't have to go create or maintain any of that infrastructure. So that's the value proposition of what Autonomy is doing. And another kind of like key decision, so currently, most of the times when I talk to someone who's built an agent and I ask them, hey, how does your agent run? They'll typically they'll figure out that like to do complex work, we need a file system. To do that, they'll give each agent a dedicated container. And then if you have 10 users, you'll be like, well, for each user, I'm going to spin up a separate container, right? But you actually don't need to do that. The reason you don't need to do that is that if you think about the state machine of an agent, it mostly is waiting. It's mostly I/O bound. It's waiting on a call to an LLM, or it's waiting on a call to a tool, or waiting on a call to the file system. It's just waiting most of its life. And if you have something like that, you can actually give the CPU to a different thing in the meantime. And a really good design pattern for this has existed since the 60s. It's called the actor model. The actor model is popularized by languages like Erlang and Scala, etc. Essentially, it's this idea that only invoke a particular thing and give it the CPU if there is a message for it. And there's a messaging infrastructure built into the runtime that allows you to share the CPU between thousands of parallel actors. And in autonomy, every agent is an actor. And that's what allowed me to run 1,000 agents in one container, and 5,000 agents in only 5 containers, rather than 5,000 containers and the complexity of Kubernetes or whatever that comes with it. Right? And we already looked at this. Applications in autonomy can dynamically provision capacity and nodes, and then they are automatically collected. So you get this ability to kind of elastically build a fleet of agents. That's what our application was doing. So now I have a couple of quick examples, and then I can end. By the way, this thing's expanding. It continues 3,000 agents at this point. OK, so I wanted to illustrate the same point in a different way. So if I click this run button, it spun up 5 different machines, and it's now spinning up thousands of agents on each of those machines, right? So that's the illustration of that simple for loop. The code for this is literally a 2-line for loop, right? So instead of you building all the infrastructure and building the capability to deal with so many agents, you write 2 lines of code, and you get this capability to spin up a large fleet of agents. And to kind of connect back to Shahram's talk earlier, which I really liked, because he touched on some really important principles, which is coding agents can be now guided to do a lot of interesting work. And so the final piece of this puzzle, in my view, is user experience and developer experience when you're building the app. And so what we've done is we've written a bunch of documents to guide Claude Code and other coding agents to build autonomy apps. So in this particular example, I'm over here in a prompt saying, hey, refer to the autonomy docs, which is a special document written primarily for Claude Code and Cursor. And I'm telling it, build an app and do all of these things with that app. But this line is the most interesting part. Deploy and test the app in autonomy. And so because in those documents are references to how to deploy apps in autonomy, how to test the APIs that get created, and how to run a loop, what you get is the ability to write the autonomy code, deploy an app to autonomy, test if it's working. If it's not working, make some change, deploy it again, and keep doing this loop until you have a working thing that meets these specifications. And I will scrub through this, but I did that exercise. And 20 minutes later, I had a live deep research fleet of agents to fact check news articles, right? So that's what you're able to do with this. And my final slide is the fact, just kind of a reminder, this was also a tweet/LinkedIn post that was going around a couple of weeks ago. But this is a person who was very senior at Google, and he's talking about the fact that all the vertical AI agent stuff that got built over the last 2 years is kind of going to get challenged very deeply now, because what's possible now was simply not possible a year ago. And so frameworks, the popular agent frameworks that you've looked at, the popular agent applications that you looked at that move emails from here to thing, those are the simple things. The next wave of agents are going to do what I just showed you through this talk. And so if you're interested in it, please scan that QR code and give autonomy a try. And of course, I'll be around and we can talk more. Thank you.
Honestly, great stuff. I know you were trying to squeeze in a lot of information in just a few minutes, But you mentioned something about how, in your opinion, like we don't necessarily have to spin up like every single agent on their own container. And I was trying to think about it. Like maybe you can share a little bit more about it, because I'm like, if you try to consolidate a bunch of, not a bunch, but like a certain amount, according to what you're saying, of workers on one specific container per se, how do you deal with resiliency? Like in terms of like, hey, if something goes wrong, right? Like how do you?
So books have been written on that topic, but this is a very foundational topic in how do you design actor-based systems and distributed systems of this kind. So if you look at languages that have now existed for 20, 30 years, like Erlang, when you create a fleet of actors, you can create a supervision tree for those actors. And this is an idea Kubernetes borrowed from Erlang. And so how in Kubernetes you see supervisors that can restart a pod. The same thing is possible in autonomy and most actor-based designs, where you can have supervision actors that spin up, that can kind of monitor failure of sub-actors and restart stuff. So this is just one way of recovery. There's a whole collection of capabilities that's baked into autonomy and have existed as patterns for a while now.
Yeah, interesting. And is it okay if I just follow up real quick? Like, so in your case, like your supervisor is running on its own thing too, right? Like within, like I'm just trying to like encapsulate. I'm trying to make sense of like how you built a sense of resiliency around this whole infrastructure, right?
So this is a long topic. We can talk later,
yeah.
but there is this philosophy from Erlang called "let it fail." And that autonomy embraces that idea as well. And that's a good topic to read on in general about how to design resilient systems. And autonomy kind of follows the same pattern.
First, just want to say, really cool product. Thanks for the presentation. I'm curious, what models are you using? And how much does it cost to run 5,000 agents for 2 hours continuously?
Very good question. So actually, there are two extremes of trade-offs I see. There are problems in our customers that are truly complex. And in those scenarios, they don't care about the cost. They care about the success rate a lot more. And in those scenarios, we are running thousands of Opus-based agents. But on the other extreme, a lot of times the problem is complex because of its scale, not because of its agentic operation, right? So think about like extract fields from PDF documents. I have 5,000 PDF documents. Go extract these two fields, well, maybe their bank statement, extract the amount of transferred. That is a simple task, and turns out models that are 10,000 times cheaper than Opus actually succeed really well. So in those cases, we're using like Amazon's Nova models are working really well. So there's a whole spectrum, and so we provide a whole collection of models that people can choose from. Yeah.
Any more questions, guys?
Thank you so much. That was a great presentation. I do have a question. Who is your ideal customer profile for these use cases, like complex research that you do? Like,
my take is actually that all vertical focused AI that was built in the last 2 years is going to need a refresh. Everybody's kind of going to start again. And so any kind of vertical that anyone is focused on where they're building a product, whether it's an internal-facing product at a company or an external-facing product for customers, we can be very useful. What we're not designed for is like little toy scripts, right? Like we're not like NA10 or whatever. We're designed for products that have many users. And if you have many users, immediately you hit these scale problems, right? If I've built an agent that uses a file system, has a shell, and I have 1,000 users, I now need 1,000 agents with 1,000 different file systems and 1,000 different shells. That's already a very complex problem, and we can tackle that in a very easy way in autonomy. So we're going after product builders in various domains.
Got it. And just a quick follow-up. In terms of the skills that autonomy is pretty good at, is that like I provide the prompt, let's say, for security search, or is that something that Autonomy also has some built-in, skills that, I can say, okay, I have a product of thousands of users, then use the security.
So there are a set of patterns built into our documentation, and Claude Code, et cetera, will refer them usually. But you can also be specific. So you can kind of like start with like a 2-sentence prompt and build it up to whatever you need in mind.
Thank you.
Go ahead.
I was asking, for the most part, Cloud Code and Cursor, I have been using like agents and sub-agents. Like in your situation overall, how did you build like the orchestrator? Because if you have like 5,000 agents and each like the summarization or compaction of every one of them to the orchestrator, it's gonna be insane. So
Yes.
how do you manage that?
Yeah, so we've written specific tools, which are Python functions, to tackle this, but it's a complex function, right? So to the parent agent, the orchestrator agent, it looks like a delegate to a fleet of 5,000 as a simple function call. You can also write custom functions if you want to tweak that. But under the hood, that tool is truly doing distributed delegation. It's managing, did I get a reply from every agent I wanted or not? It's doing kind of batching and compaction and reporting back in like some sort of summarization format. Oftentimes the file system is very useful where you can say, hey, I took the response of that parallel fleet and wrote it as individual files. So you go and traverse that file set whatever way you best are capable of, right? So that's a good handoff mechanism for really large sets.
Okay, so just to clear, so like in case of like 5,000 agents, and you have like a model that is not like big of a context like window, you save them as like empty files or whatever, and
Not empty files. You save them as results, right? So you're doing like a map reduce in that scenario, right? If you have 5,000 agents. So you take the map and reduce and take the final result, either fully reduced or partially reduced, and write that result down to the file system. And then you tell to the parent, hey, I have taken all the responses and written to this location. Go deal with them over multiple steps if you need to, right? All right, I think we're over time, but thank you all. Thanks a lot.
Yeah. So thank you, Cleric.